Okay, good morning everyone. So for today's topic, we will going to discuss interpolation in computer vision. Actually, last time we already started within this particular topic, no? So talking about image transformation, particularly from an original image, and then we're trying to transform this. So we have taught how to do scaling, no? So how does the scaling factor would affect us to transform a certain image into a resultant image, or what we call the destination image. Okay, so last time we have figured out some solutions. I guess we know that there's some certain problem in image transformation when we use direct transformation. So although it looks like that every pixels, no, in a certain destination will fill up yung original image natin, we can see that there are still problem that might exist. Okay, so again, we can have the transform image, no? So let me have it first here. Okay, actually the transform image can be represented as p prime is calculated using the direct transform. We have the equation s as our scaling factor multiplied by our the matrix of the original image, no, which is p, no? So it found out that a certain image, just like on the given part, could be like in discrete form or a continuous signal. So just like what we have it here. So if this is our original image, and then we're trying to calculate the transform image, no, we could have an instances wherein the scaling factor, which could either be a continuous, just like what we have here, no. Yeah, just like a point 0.5 as a scaling factor. Okay, if let's say our image originally positioned to a coordinate or the pixel element coordinates of 1 and 7, so we could have a transform value of around zero point 0.5 here, and then 11.5 now, which could be a continuous form. So if you're going to locate that, for example, this is a reference, we could found out that this particular location, which is zero point 0.5, so roughly if this is like row 1, so roughly it's like zero point 0.5, and then the column is around 11.5, no, at a certain point we could have this particular representation that the transformed value or the resultant value could be a continuous form, no, just like what we've seen here. So what we're actually doing is we're trying to apply an algorithm wherein we can copy whatever the density that were placed here into the resultant destination, okay, on our calculated image. So if we found out that the direct transformation wouldn't be enough to handle continuous image, because the density that we could have here could vary based on the combinations of the different densities around this particular value. Okay, so what we're trying to discuss last time, that it could be calculated in such a way that the we can apply the inverse, okay, transformation between this part. So this is the intern. If we apply the inverse, so we can have somehow analyze that the destination image could be calculated with respect to their inverse scaling factor times the p dash, no, or the inverted value of our form. So in this case, we actually discuss transformation using the nearest neighborhood. So let's say referring to this particular position, so this dot, no, or this corner represents the positions of the y, okay, or the row. These are the rows that we could have it here. So we have here row 1, and then under 0 1 2 column 2, okay, and then we have here row 1 column 3, okay, then row 2, okay, column 2, and then row 2 column 3, something like that. So this position might be in like less than or in between, okay, row 1 and row 2. So we could have like something like estimate that this is around, let's say for example 1.6, okay, and then the column, okay, so it's in between um 2 and 3. Okay, so let's say around 2.5. So this is an example of a continuous system. So if we substitute it here, so something like originally, let's say we could have like 1.6 and 2.5 here can be expressed in the inverse, okay, of the scaling factor, okay, multiplied by, let's say, originally from there its position. So we're trying to copy the coordinates, let's say from 10, row 10 to 20, and then put it inside this coordinate 1.6 and 2.5. So the question is, how which intensity, no, because we have to copy intensity. So let's say this intensity is around, you cannot say that this is like 255. So this 255 intensity should be put, okay, within the destination coordinates, which is 1.6 and 2.5. So happen that 1.6 and 2.5 cannot be exist here, right, or is not existing here. So basically, if you're going to understand or to analyze what the nearest neighbor algorithm looks like, okay, so the algorithm would actually look for the nearest, okay, coordinates, okay, or the nearest point here, okay, to on this particular position. So if you look actually here, the nearest neighborhood would be around 2 comma 3. No, so if you're going to understand that 2 comma, or sorry, the nearest neighborhood, if we're going to perform rounding off, is around here, no. So if you round off, okay, yeah, exactly, is it correct? So 0 1 0 1 2 3, yes, exactly. Okay, then 0 1 2 3 4. Okay, so we can actually round off, no, yung particular position natin, okay, such a way that it could be located within the nearest neighborhood. So if you're going to look here, so we can round it off to 2, then this one is 3. So the position of 2 comma 3, okay, should be here. Okay, so instead of 2 comma 4, because originally on direct transformation we found out that this can be converted within this 2 comma 4, it should be placed here, or the density, this green part, should be actually placed here if you're going to apply the nearest neighborhood or neighbor interpolation. So we use the term interpolation because we're interpolating, no, whatever the coordinates that it should be worked, no, so within that form. So it comes out that there are also other ways on how do we interpolate, okay, a particular form, okay, just like on the given scenario. If we perform nearest neighborhood, okay, so it so happened that this density, or the this position should copy the density, okay, which refer to this part. So but these are different, like variation density. Just imagine if this density is around 100, then this is around 250, and then 255, then this one is, let's say, 80. Okay, so therefore the density 255 will be copied, okay, since this is the nearest neighborhood, directly on this particular position. So if we look again on our sample simulation using nearest neighborhood algorithm, so let me shift to my Jupyter. Okay, so this is our last Python code, no. So we're actually done with displaying the or calling the method for displaying actual image, and this is actually the code for inverse scaling. So remember again, what we're trying to do here is to apply the nearest neighbor on within a certain index or coordinate. So just like on the given example here, we, let's say for example, applying a scaling factor of 2, or multiplying our dimension into 2. So this particular program will determine the transform image using the inverse, okay, of a function. So looking on this particular code again, we're trying to get the inverse of a certain array using the linear algebra. So this is a method that we apply using linear algebra by inverting our scaling factor here first. Then after that, we can now calculate for the p dash, or the transform pixel, using the total number of rows and columns, or the shape, okay, that we are generating here. Wherein it so happen that we, what we do here is we copy, or we calculate the shape of our original image and then convert it into another value such as new I and new j, not to locate the total number of rows and columns into a transform image. Then after that, again using the mathematical equation that we have, So we can apply the inverse, okay, of our scaling factor, which is this value, within the transform original value that we have a while ago, or direct transform, which is p dash, okay, and then we can now have p. So you will notice that there is a method here, or a function, that will use floor. So remember last time the difference between this floor value. Okay, so floor, actually, if we're going to run a code in Python to understand what's the difference between ceil, floor, and round, because these are the parameters in a float estimation, no? So the sample program that we used last time is actually use floor. So what happened if we're going to run this particular function into a certain float? Let's say I have a float here which is 2.3. If I run what's the float of 2.3, it will be converted into 2. So floor means it will be like approximate into the least whole integer value, no, or parang round off. Okay? Below dun sa mismong integer niya, which is 2. So that's why the answer here is 2. Then if I have, let's say for example, the ceil, just like what the term itself, on the other hand, i-round up niya naman, no? So yung floor is, it will automatically round down to the lowest integer value. Ceil naman would automatically round it off to the nearest whole number. The difference, if we use rounding off, so basically round function will follow the rounding rule, no? So if it's like boundary from point 0.4 to point 49, okay, it will be like round off. But if you have the value, if I change this to, let's say, 2.5, okay, so still it will have that form, or 2.6. If that is in round, it will automatically round up. So here, what we're trying to do here is we need to calculate the nearest neighborhood. That's why normally in some of the reference, no, if we use, let's say for example, we're trying to use here round instead of um floor, because imagine a while ago we showed that this the value, okay, originally on original in nearest neighbor, it actually follows rounding, okay, rounding off value. Let's say 1.6 will be round off to 2, and then yung 2.3 will automatically round off to 2, no? So following that form. So if we run it here, okay, and look on for the display or the actual image, okay, so it's still processing. Okay, let's wait for a while, okay, so that we can see how the image will be transformed. So actually this is the standard form on how we do inverse scaling, no? And then you also found here that there we actually use if else condition, because just like what I show you, there are instances that if we round it off, okay, yung value ng ano natin, ng coordinate natin would either be within the given coordinate or outside the given image. So it is really important to determine here kung yung na-calculate natin na value is within the row and columns here. That's why we put it here. Okay? Although, okay, assuming that on the given example, since we're using shape, it won't get out doon sa mga coordinates natin. Okay? So yeah, let's wait for couple of seconds before we can see the actual output for this. Okay, so here's comes the output, no? So using the round function, so we see here this is the actual image. So again, we create a function here, not to display the actual image size, no, instead of displaying the image using the traditional in OpenCV. So we actually create here a function that would automatically display the actual size of the image, regardless kung anong method or anong function na niraran natin. So every time I call for this method, definitely whatever we see on the screen is the actual image size. So you can find it there. There's no big difference at all, right? If I compare floor into the rounding off. But as I was referring a while ago, the standard method or function for applying inverse scaling is using the round, because if I use floor function, as I told you last time, no, so a while ago, okay, it make sense, or it make have some error if it does not actually capture yung intensity outside the given instances. So for example, if I go back with my PowerPoint presentation, Okay, going back here, so best practice is to use the round method instead of floor, so that if once you run it again, it would basically calculate yung pinaka nearest ka talaga. Kasi just imagine if you're going to apply floor here from 1.6 comma 2.5, the result will be somehow like 1, and then yung 2.5 will be like 2. So 1 and 2 will be here. So it's not the nearest actually, 'di ba? So visually, the result might be instead of the nearest, if we use floor as our method, it will actually calculate etong corner na to instead of this method. That's why if you're going to apply round, just like what we do, 1.6 will be round off to 2, and then 2.5 will be round off to 3. So 2 comma 3 will be the nearest and exact interpolated coordinates here in this particular um, pixel, right? So the best or the standard way of representing nearest neighbor interpolation is using the round method. Okay, so we can see it here that this is one of the most common, but as I was saying a while ago, hindi lang naman yung nearest neighbor, or previously, not only the nearest neighbor would be the probable or possible solution for transforming a particular image, no? Although this is like normally used, okay, to apply interpolation, we can also apply it other way, because imagine if we're going to have a nearest neighbor, there could be an instances wherein if this is like four corners, and then exactly the transform image using the scaling factor is placed in the middle, so it's really hard for us to determine which among the four here will be the nearest neighbor. Okay, so with that, we can also use other types of interpolation, which we're going to continue discuss for this particular session. Okay, in the previous slide, we talked about the nearest neighbor interpolation. I also tell you that there are other better ways of interpolating or performing interpolation better than the nearest neighbor interpolation. So here's the example, no? So let's say, for example, that this destination location, okay, which is here. Say, for example, this is our destination location, and this is the actually the location that you're going to, if we perform inverse transformation, let's say the location is no longer discrete, no, just like what we have it here, okay, and that doesn't map into one of these nearest location. So there's actually one way is just to pick the nearest neighbor, just like what we do here, and it will just have to copy, no, whatever the density here or intensity of this nearest neighbor. Okay, now, if we're going to analyze this logic, another way is to pick the intensity. Okay? Ito yung isang interpolation natin. We're going to pick the intensity, okay, of these different four corners. So, and then we will take the average, no, between these four. We call that the weighted average interpolation. So, let's say, for example, how do we deal with that? So, let's say, for example, the intensity of this corner is 200. Okay? Then let's say etong corner nito, intensity is around 255, for example. And then let's say this is any value 100, and then let's say 80, for example. Okay, so given the intensity of this four different corners, one way is to generate yung pinaka resultant intensity. Okay, so let's say, for example, I'm going to create an equation of G is equals to, we're going to apply some certain average, no, simple average between these four intensity or density here. So if we're going to perform simple average, so we have this certain equation that we will calculate the average between four densities. So if my given is 200, 255, 180, so I'll get the average for that, and then whatever the value that we have it here will be the density, no, that we're going to copy and apply doon sa position natin. So instead of just getting the density, no, nung ano natin nearest neighbor and apply it here, okay, on this case instead of 80, what we actually do is calculate the weighted average. So that's the idea, or the simple average between this certain image. But if that will be the case, simple average won't satisfy yung tinatawag natin na analysis, no? So, considering this different abilities, I mean, the source location is actually capturing four different intensities that we could have in its four neighbor. But it also turns out that some of the neighbors here, just like what we have here, are really near to this certain position or inverse location. So we are going to give some, you're going to apply equal weight. For example, to, we have like 1 over 4 multiplied by 200, then plus 1 over 4 multiplied by 255 here, plus 100 multiplied by um sorry, 1/4, 1 over 4 multiplied by 100, and then 1 over 4 multiplied by 80, given the exact weight. So basically, let's say W1, which is the first weight, okay? Then eto yon. Now we're trying to use same weight na between these four intensities, okay, or densities. So we could have it like exactly equal to 1, no? Such that if a certain location, for example, is much closer dun sa candidate location natin, because this is our candidate location, no, right? In the, if using the nearest neighbor, then the weight of the this entire thing, okay, is equals to the 1, no? So the irrelevant intensity should be higher, no? Kung sa analysis nung weighted, we call this like weighted average. So what we're going to do here is we're going to apply some certain weight. Okay, so yung relevant weight natin should be higher, in particularly doon sa nearest neighbor, ano niya, neighbor case niya dito. So on this, so dapat yung intensity 80 would give like higher weight compared dito sa mga intensity nitong other neighbors na to, because this point is much closer, no, doon sa neighbor. Although we will not copy the exact intensity, which is 80. So bibigyan din natin ng parang right yung other neighbor para mag-take effect doon sa interpolation natin. So what we're going to do here actually is we're going to analyze the weighted average, no, formula in having this particular analogy, no. So how does it deal? So even after that, we're going to apply yung weight, they should add up to make one more. So the idea is we're going to think kung ano yung mga certain weight that we add, once we add up, it would still be equal to 1. So it won't modify yung mismong ano natin, value natin. Okay, so how can we model it that if this is like continuous coordinate? So they are close dun sa discrete natin. So the density of that location will get a higher weight. For example, here, this one, kung sobrang close siya. The rest will be like equally divided. Then once we add it up again, that should be equal to 1. So that is equally all. So if the location, for example, if the candidate location is exactly on the center, just like what we have a while ago, and then everything is equally distant. So pwedeng applicable, no, yung ganyang weight kasi nga centered siya. But that's not normally happen, no? So this one could make uniform thing. So it might happen just like on the given case that we have, that the position is somewhere like skewed here, no? So the intensity should be like yung priority niya, if we're going to have it like tataasan natin yung weight dito sa my corner na to, and then the rest we're going to have certain weights again, and then we're going to get the average. So how we can model that? Okay, so let's analyze it here. Okay, in interpreting that, we have to analyze what we call the weighted average interpolation, or some of the reference use the term bilinear, okay, interpolation. So let me also use that term, okay, so that if you have some other reference at all, you might deal with this particular term. So we have to deal with the importance of the weights. Although there are multiple I'm going to talk about one of the very famous techniques of doing these things. We call this as a bilinear interpolation. So to understand the bilinear interpolation, it is, by the way, don't worry about the term interpolation. Okay, so it's some kind of weighted averaging. That's why I introduced weighted average a while ago. So you can just even rename this interpolation as some kind of weighted average, and that's the interpolation means, no, weighted average. Okay, so to understand the bilinear interpolation here, it is important to first understand muna yung linear interpolation. So let's make an example. Okay? So let's say for example, we have a pixel location here. Let me draw this. And let's say yung coordinate nitong pixel na to, let's say the coordinate of that particular pixel is for example, the row is 200. Okay, let's say, and then yung pinaka column niya is let's say 100. And then yung intensity of that particular row is let's say 50. So parang I'm referring to this for example, no? Okay? And then we have another corner here that the row kung align siya, syempre pareha siya ng certain row, okay, nagkaiba lang siya dun sa column, increment by 1 if we're referring to syempre discrete would automatically increment by 1 lang naman tong row natin. Okay, let's say for example yung intensity na nilagay natin dito is 70. Okay, and then keeping same. Okay, and then after inverse transformation, actually let's say yung na-transform image, syempre nandito lang yun, no, in between this particular position. Let's say for example it exists on this point, no, or sorry, let me give some parang mas unique na difference, no, kasi pero itong gitna equal ano pa rin sila, no, equal position, so hindi natin makikita yung difference between yung nearest, no, doon sa in-apply natin na weighted average. Actually we're still applying nearest, pero we also consider yung weight doon sa other neighbors niya, no, hindi lang doon sa pinaka malapit. That's why this method can also or can are being used, no, word famously in transforming an image much more particular with the densities around them. Okay, okay, though, so let me put the point in this part, no, let's say here instead, no, para mas clear na makita natin na mas close siya dun sa my right side. So okay, let's say for example, let me write the location of this point. So syempre parehas sila ng row around 200, but the column is in between 100 and 101. So let's say for example 100.7. Yan, para mas ma-correlate natin. So mga yan 100, ito yung position 200, 100.7. Okay, and I want the intensity at this particular location. Okay, and if you see here the analogy, I'm just thinking that the point lies between this 2 point, no, yung 200 100 sa akin 200 101. Okay, so we'll see if the point lie inside this particular 4 point later on, but let me analyze this. So but right now let's have this analogy muna do sa pinaka upper corners nito. Ito muna ng dalawa, no? So now meron tayong identify na distance. So if you this particular point, no, as we're referring, the distance from this point up to this corner is around 0.3, right? Kasi ano to 101 and this is 100.7. And then the distance from this up to this parang itong corner natin, itong corner 1, corner 2. If I write it here, corner 1, corner 2. This is around 100.7 minus 100, so 0.7. So basically, kung titingnan natin, mas close siya doon sa point na to, no? Itong pangalawa, itong 2. So therefore, pag mag-apply tayo ng weight, dapat we're going to have certain weight. Let's say for example, weight here, then another weight, W1, W2, for example. The W2 should have at least more weight, no? So yung weight na i-apply natin dito should be like more than this part. So this is actually the weight that we have. So correspond to the 0.3, 0.7. So what we're going to do here, okay? So basically, we're going to apply, no, yung analogy natin dito, no, kung paano natin i-apply yung bilinear interpolation. Okay, so what we're going to do here is we're going to analyze it based on this perspective because the distance between them are given, no, yung 0.7 and 0.3, and this particular distance, because it's like 100.7 and then 100 and then 100.7, 101, so we have this particular 0.7 and 0.3 distance. So what we're actually do here is to pick this particular weight, now referring to 0.4 or 0.3, sorry, on my example. Okay, we will pick the distance, and this distance will be yung pinaka-weight nitong ano natin, no? Intensity na 50. And then on the other hand, this weight which is 0.7 will be the weight naman between this particular intensity. Okay? So the equation now, okay, if we're going to compute the resultant intensity, what we're actually do here is to multiply yung pinaka weight natin na 0.7, okay, doon sa intensity, no, nung corner 2 natin, which is 70. Then the weight of 0.3 will now be multiplied dun sa intensity natin na 50. So you will see here that the weight applied doon sa closest intensity or closest corner will be like higher than the intensity or weight applied doon sa intensity doon sa my left, because that is much farther than doon sa ano natin, no, doon sa 200 100.7. So this actually give justice, no, doon sa particular position na mas malapit. So we're giving the weight actually very intuitive yung logic, di ba? So, still 0.1 to pag ano natin na kinumpay natin 0.7 by 0.3. But here, we can see that the intensity applied here, or the weight applied on the intensity 70, which is much closer dun sa position natin. So, parang it's still vary the nearest neighbor in such a way that we're applying a certain weight, no, balance doon sa two corner natin. Okay? So, if we draw yung analogy natin, so we have here yung candidate natin, no, dito sa point 4 natin. So na-analyze niya, no, yung analogy niya, okay? So parang magkakaroon tayo ng certain output dito, no. So ito yung output natin doon sa product natin ito, and then the output here. So you will see here that the intensity, okay, would actually vary, no, doon sa much closest part natin, no, which is this side. Okay, so this is the more candidate location which is closer dun sa port natin. So I'm referring to this particular corner applying yung pinaka weight natin. Okay? So that's the logic within that part. But anyway, doon sa mga horizontal part natin, we will do that interpolation using that particular analogy. So we have here this particular instances wherein we multiply this weight doon sa density nung pinaka farthest, and then etong weight natin doon sa mas closer given this particular scenario. So if see weight here, they will add in it equal to 1, right? So that's one of the very beautiful way of doing this linear interpolation. And then yung final result would actually look like the weighted average, no? Wherein the weights are computed doon sa particular equation natin na to. Okay? So, I hope you understand. So, let's take an example naman. That's the bilinear transformation. So, now think for example, let's say, okay, now if I apply the logic dun sa bilinear interpolation, sorry, if I, let's say, given yung intensity na ginamit natin na given example, this corner is 50, and then this one is 70, let's say for example 125, and then this is the brightest around 255. So again, in nearest neighbor a while ago, definitely it will get exactly the intensity do sa pinaka nearest. But then since this is weighted average interpolation, we're actually varying yung weight dun sa mga different neighbors. Parang ito yung weighted average natin, no? Okay, what we're going to apply here is to analyze yung linear interpolation dun sa apat. So let's say for example, if that would be the case, so we have here four different corners. So let me draw it here. So let's say ito yung merong intensity na 50, then 70, then this is like 125, and then this corner would have like 255. Considering their coordinates, so we have here 200, 100 kanina. Then this like increment by 1, right? So 201, 100. Row corner nito is 200, and then 101. And then this one is 201 at 101. So importante natin ma-identify na. Okay. So let's say for example, okay, this are our coordinate system, and then nandito yung pinaka certain location natin which is placed here. Okay, let's say for example nandito. So what we're going to apply, no, here we will going to write the location of that this particular pixel, and then let's say the coordinate at this point is definitely more than 200 yung ano niya, yung row, right? Okay? And then yung column niya is between, so roughly dito sa row natin. Okay? And then the column is in between 100 and 101, no, dito sa particular position natin. Okay? Let's say for example, I'll write it as, magbigay na tayo ng value 200.7. Then the column coordinate here looks like maybe around 100.8, no, kasi in between 100 and 100.1, no. So parang kung i-determine natin yung position na to, no, kung ito yung reference natin. So one very common kind of things to do here, the two linear interpolation that we applied a while ago. So one linear interpolation will consider the intensity, no, from this point, no, ito yung ina-analyze natin. And then another, yeah, this linear interpolation, no, dun sa horizontal. And then syempre yung position na ginawa natin kanina, ito, horizontal interpolation. And then we're going to apply vertical interpolation then on this particular point. So that's how this logic will be performed, no. So here, most probably, no, let's say the intensity is around dito 200 comma 1, kung ito yung gagamitin natin. So this is 100.8, right? So pag-apply natin yung method na ginawa natin kanina, so what will be the weight within this line? So I write it on this point, no, para much clear. So kung 50, and then yung sa kabirang side niya is 70, then in-interpolate daw natin on this part. So this is our x. Using yung point na nilagay natin, 200 point. So 200 to, 200, comma 100. So this is like 200, comma 100.8, right? Kung interpolate natin to sa position na yan. And then nandito yung 200, comma 101. Right? So the formula will be like, this is the weight is from this point, 100.8 to 101 is 0.2. Then this one is 100 to 100.8, 0.8. So, ano yung magiging formula natin? So, the formula will become 0.8, which is the weight dun sa left, multiplied by dun sa intensity on the right, plus 0.2, which is the weight on the right, will multiply on the intensity on the left. Right? So, it turns out that this will be the ano natin, no, yung interpolated value natin. So, we will going to do one more linear interpolation and map at this point here, and then the linear interpolate between ito naman, no, yung sa point. So, ito yung interpolated value natin dito, part na to. Okay? Then, we will also do it dun sa other interpolated point in between. So, parang dito naman sa horizontal part na to, no? So, okay, so logically, hindi yung gagawin natin dito sa may babang part na to. So, on this part, no, this side na to, what will be the equated formula? So, ilan yung weight natin dito sa may left side still 0.8 multiplied dun sa right intensity natin, which is 255. Okay, let me just check if this still recording. Yeah, thank you. And then plus multiply natin yung 0.2 doon sa left intensity natin given here. Left intensity natin is 125, no, dun sa corner natin. Okay, so this is for that horizontal linear interpolation here. So magkakaroon tayo ng parang two certain values here, do, na interpolated dun sa part natin. Okay? Okay, so let me draw this na to analyze. So let me write this intensity as so whatever the result that we have turned out here, no? Ito yung pinaka-result natin. So the result that what's turned out here, let's say for example, I just use this side, turns out to be our, let's say, A. No, kasi interpolated yun dito, di ba? No, itong A natin, ito yon, and then this will be our B. No, so parang this is our X, and then we have this, now from this point, X. So we're going to determine this part and then this part. So let's name this as A, no? Itong point natin, and then this one is for, let's say, B, no? Then yung original perspective natin from our point is 200.7, then 100. point 0.8. So magkakaroon tayong certain point dito between A and B. Coming from the result here, this is our A, and then the result here, which is our B. No, so we'll like wait for like B here. No, after that, interpolate naman natin siya vertically. No, so there's some weight here, whatever the result that we could have, diba? We have some values here, okay, for A and B. Okay, definitely yung position ng ano natin nung um, column for that, let's say for example is we will going to apply, yeah, kita naman natin yung difference natin dito, 'di ba? From 200 eto, and then 201. So ang difference natin dito, ang weight natin dito is 0.7, dito sa baba is 0.3. So what we're going to do, same way, by linear interpolation, yung 0.7 naman yung i-multiply natin sa intensity na na-calculate natin kay B. Then yung 0.3 will be the value which we're going, or weight which we will multiply doon sa value na na-calculate natin within our A. Okay, so on this particular point, we can now get the exact intensity value, no, between dito sa ano natin, analogy natin, considering the weighted average of these four different corners, no. So of such, this is one more common and much more famous method of interpolation. So we call this again as bilinear interpolation. So now let's have the example in Python on how we are going to use this bilinear interpolation. No? So let me move again on my Jupyter notebook. Okay, so I also have here the code, but again, I promise I'm going to update yung Python notebook code na to, and then I'll upload it in our canvas. So we will see here how we're going to apply here. So what I'm going to do here is I will create a function, no, with my bilinear interpolation, no, with respect dun sa ano natin, no, reference natin. So again, we see here that we should apply a method or function that will determine yung mga corner natin, top rows, top columns, bottom row, bottom columns, even yung left corners and right corners here. So we need to do some certain functions that will perform this particular algorithm. So again, going back on my um, Jupyter notebook. So we talk about bilinear transformation interpolation, and we also already have implemented yung nearest dito. So what we're going to do here is actually we just have to apply, no, yung particular function na to. Ang maiba lang is this, instead of calculating yung direct round off, we're going to perform yung weighted average, or yung tinatawag natin ng bilinear interpolation, no, na i-call natin dito before we going to transform yung mismong image natin. So this part won't be changed, no, kasi this is the inverse function, inverse scaling, but instead of getting the nearest neighbor, we're applying here the bilinear interpolation. So much more ano siya, equally distributed yung intensity or density among its neighbor. Okay, so here, okay, so we're going to involve yung rating average and yung different parameters that we have here. So rather than yung pinaka nearest lang, so I'll call my method here as bilinear interpolate function, okay, wherein the given parameter as follows. So kailangan ko ng row, okay, row, column, saka yung pinaka index, no, nung ano natin, no, yung nung image natin. Okay, so yung I natin referring to the index kung saan ko siya ilalagay. Okay, so it will receive yung again yung row, column, and then yung, and this again I'm referring to candidate row and candidate column, no, kasi meron tayong mga certain row and column values dito. We have 4 candidates. So let's say assuming, no, ito na yung niran ko na kanina, yung grayscale image natin. At this point, I really want to interpolate, okay, yung itong point na to dun sa image natin. Okay, so we can assume that this green point has continuous coordinate, as I was referring a while ago. So first of all, I need to check that this certain location that we're going to interpolate is inside, no, yung mismong boundary natin. So otherwise it will just return to 0. So what I'll do here, okay, on my line number 2, if r is greater, let's say dito muna, okay, dito sa point natin, if the top row, let's say for example, is greater than or equal to 0, line number 10, and yung BR stands for bottom row, okay, here, is in the given shape. So, I need to check no yung ano niya, no, yung identity na. So, anyway, let me type it this from scratch, no. So, let's say for example, so that we can understand. So, if okay, anyway, let me just so if the row, sorry. Okay, again, if let's say for example, if my if the row, okay, let's say like if R, assuming this is like the candidate row dun sa green part kanina, should be what? We have to think that it should be like greater than or equal, no? Doon sa, what's the parameter? Doon sa part natin. If R is greater than or equal to 0, and then definitely, and R is syempre within our or inside the boundary, so I call for the shape, no, of our image. Okay, which are referring dun sa first natin, so sa row natin, so we have here like index 0, and sa part naman ng column natin, it should be like greater than or equal dun, then with 0, and it should be less than, no? Bakit hindi less than or equal dun sa shape? Because again, the index of the shape always starts with, or the index with always starts with 0, no? So, if we're going to include equal, then definitely lalagpas siya dun sa, ano, no? Dun sa boundary ng mismong, ano natin, no? Yung mismong shape ng object natin. So, yeah, sorry. This should be like, yung value, no? Nung ano natin. So, then we have here this actually R. This will basically return the yeah, let me compute, no, yung particular column, no, dun sa part natin. Okay, so column here which we have like left index and then right index. So let's start first with left column is equal dun sa actual value ng ano natin, no, ng column natin. And then let me have the right column index, which is the index dun sa pinaka left natin. So, paano natin yun? So, left column plus 1, right? So, then, we have, for example, no, dun sa case natin, sa kanina, no, dalawa na yung ano natin, or dito pa lang, no, left column or the right index natin. Okay, so we will now compute yung mismong weight naman dun sa left and right index, just like what we're doing here, no? Okay, again, what I'm pertaining here, this is my for every corner, meron tayong left value or dito sa value natin left corner, no, and then yung right corner natin. So that's what I'm pertaining to have it here. So right corner is always like left corner or increment by 1, no. So yun yung ano natin, just to be clear on this particular variable. So that's the actual position, no, nung ano natin, no, nung left corner, right corner. So what I'll do here now is I'm going to calculate yung weight, no. So basically you have to read for the right pixel. So I'll name this as my weight on my right pixel. So it's basically the distance. So yung particular distance natin. So paano natin i-analyze yung distance? So here the distance is basically No, ito, no, yung position nung distance natin, or whether the value is minus dun sa left, okay, and then on the right. So we have to determine yung difference, no, between this point and then this point, no. So how do we calculate that? So weight on my right is equals to yung pinaka column natin minus yung left corner, right? So kasi ito yung pinaka left corner natin, no, dun sa weight natin dun sa right, 'di ba? Baliktad. So we apply the weight of our right to be applied doon sa mismong intensity, no, itong intensity nung natin left corner. So paano natin kinukuha yung intensity natin? So yung column minus yung left column. So yung column natin dito mina-minus natin dun sa left column. So we have here 100.8 minus 100. So that's what we're actually doing on this particular line. Okay, so I hope you understand that particular part. So since it's a method, everything will be like variable. So pag kinol natin, automatically it will read yung rows and column. Okay, then same way, yung weight on my left naman. So basically nasan yung pinaka weight ng left natin dito. So eto, yung weight na to is i-multiply naman natin dito sa value. So kailangan malaman natin naman yung mga value dun sa right. So right column minus yung pinaka column natin. So I'll write it as weight on my left is equals to sa mismong right column natin, okay, minus yung pinaka column na natin, no, na value natin. Okay, so that's what we're doing here. Okay, so there are two weights involved here, no, yung weights ng left and weights ng right, standard value natin. So on the candidate intensity naman, let me call the candidate intensity here. So yung candidate intensity is this one. So yun nga yung kinakalculate natin. So how do we calculate that? So basically we have to candidate intensity muna natin. So horizontal, we name this as kanina, 'di ba? We name this as this one, as A. So A can be calculated so can we calculate A directly? We need to calculate first muna pala yung top row and column kasi we still don't have that top row and top column. So instead of calculating directly, so I need to get my top row muna saka yung top column at the same time, no? Okay, so for my top row, okay, so it's actually the just like what we do a while ago, we need to get the integer value, no, nung mismong syempre row naman, no, just like what we have do here, no, previously dun sa column, no. So para naman to sa vertical interpolation, para isang calculation na lang tayo, no, dun sa A and B, vertical or horizontal and vertical interpolation. So after I have my top row, I can now get the bottom row, okay, which can be again dun sa reference natin. So that's top row always increment by 1, okay, and then yung weight natin within that particular top row or top weight for this density is basically particular weight, which is yung bottom row natin, tama, i-minus natin dun sa mismong row, no, nung value natin, and then for the weight naman do sa bottom, okay, so ito naman sa vertical, no, we're going to subtract yung row natin dun sa top row. So parang yung analysis rin natin dito, but again we're doing it like vertically naman, no, dito sa part. That's why we're determining yung bottom and top row dun sa particular value natin. So again, BR means bottom row, TR means top row. Okay, tapos meron tayo ditong left corner, right corner. Okay, left column, sorry, and right column, no. C means column here, not corner, no. Then after that, we can now calculate, okay, yung A and B here. So how do we calculate A a while ago? So kanina dapat ika-compute ko na, no. So yung weight ng left and weight right. So now we can perform the interpolation here such that yung weight ng left natin will be multiply dun sa index nung, okay, sorry, index should be something like this. Okay, so the parameter will be like top row and left corner. So that's the first one, right? And then plus yung first corner natin. Sorry, plus. So ulitin ko, what's this? Weight ng left. So pinagpalit na natin kasi dito, di ba? Weight of our left column, this one, ito yon, ito yung pinaperturn ko dito, is equal to the weight, okay, nung ano natin, WL natin, which is RC minus C, multiplied by yung mismong value nung pinaka, ano natin, right, di ba? Ito yung kabaligtaran. So left natin, distance, okay, ito yon, multiplied by the intensity dun sa right. That's why I call R and then yung location nung ano natin, no, nung mismong column natin. Okay, plus what's the other parameter? So ginagawa natin ng ano, no, ng function, no, yung mismong analogy natin, no, dun sa bilinear interpolation. So we have here weight on my right naman should be calculated within the index of my TR, no? Okay, and then yung ano natin, no, yung RC, diba? Yung ito naman yung ano natin na right corner or right column. This one is the left and then this one is the right. So left multiplied by right, okay? And then yung right should be multiplied dun sa ano natin, index corner natin or column natin. Okay? Then for B, that should be what? So B here should be B is equal to weight nung left, okay, multiplied by again weight of the left multiplied by the intensity naman nung mismong rows naman natin, no? Kasi ito yung vertical, no? Bottom row, then left column. Okay, then plus, sorry. So, what's, ano ulit? Ano yung B ulit natin? Sa may pinaka lower right natin dun. Right, so, we have to do naman, ang parameter naman, yeah, iniisa-isa ko yung parameter, kaya medyo matagal, sorry. So, we have here bottom row and then yung right column. Okay? Yeah, I think this is correct. And then, syempre, yung kinalculate natin overall, yung pinaka-resultant index natin, yung G, no, on this case, no, G should be the overall, no, na value natin between yung A and B natin. So, yung, ano natin, yung weight natin, WT, on top, multiplied by yung A, no, tama, then plus, yung W ng bottom natin sa vertical multiply naman kay B. Okay? And then ang nire-return natin ditong value is G. Yeah, let me run this. Yeah, it accept, no? Pero hindi pa natin nako-call, no, dun sa function. Okay? So now, this will be your assignment, no, or task for today. Okay? For the remaining time. You have to modify yung program such a way na ang gagamitin natin dito sa transformation, instead of using yung nearest neighbor here, you have to use yung bilinear transformation na function na ginawa ko dito, no? So what I'll do is I will upload this Python notebook including tong function, okay, or you can also fix this kung magkaroon ng error, and then call it inside this inverse scaling, okay, and you have to submit yung modified code in our canvas. Okay, so that's our goal for today, no? So sa ano nyo, sit work nyo for today's task. So you have until ano naman within our period to modify it and submit it, this code. If time won't permit, then I could extend it. Okay, thank you.